Hi, I'm Theresa Urban. I'm a vice president here at GDIT in the Defense Division's Growth Organization. We are here to discuss operationalizing digital engineering, and I am joined by two fabulous panelists. Mike, why don't you go ahead and introduce yourself?
Hi, Theresa. I'm Mike Nash, Solutions Director of Digital Engineering in the Defense Organization at GDIT.
Great. Travis, please introduce yourself.
Good morning, Theresa. Travis Dawson. I am a Senior Program Director within our Air and Space Force sector.
Awesome. Great. Thank you. So before we actually get the conversation started, I think it's really important for the viewers to understand what is digital engineering. Mike, why don't you take that one?
Sure. I often like to start with a definition. So the DoD defines digital engineering as the usage of data and models throughout the systems engineering lifecycle, from development to test and evaluation to sustainment. And I often simplify that as automating our existing systems engineering processes, often through software to do that automation. And I found that in today's world of overwhelming amounts of data, this preponderance of data, very complex systems, they overwhelm our systems operators. So we need a solution that simplifies organically and extracts authoritative sources of truth so that operators trust the information that they're seeing. We call this authoritative data ASOTs for short, authoritative source of truth.
Mm-hmm. Excellent. And Travis, what does that mean to you from a program manager perspective?
Sure. So it impacts or should I say benefits the triad of program management of cost, scope, and schedule. The ability for our engineering teams specifically to have authoritative data, for one, and to have quality products is paramount to the success of a program.
Awesome, thank you. And so here at GDIT, we look at solutions kind of as a whole, and we try not to get into like what we call a vendor lock situation, right? And I think a lot of times our customers are concerned about that. So how can our customers, move toward digital engineering and avoid a vendor lock situation?
Yeah, great question. I'll take that one. So I believe that digital engineering should be open for everyone. So it shouldn't be just a one-stop vendor shop that can lock an organization into a very expensive agreement for a long period of time. So part of our approach here at GDIT is the usage of standards-based modeling and open source solutions to define what digital engineering is. And really that definition is what I call digital threads. And a digital thread is merely a use case or the relationships among pieces of data that provide an answer to an engineering question. So by using standards-based models and open source solutions to define these digital threads, agencies and organizations can find themselves in a position where they can move freely between different vendor solutions as their requirements change over time.
Awesome. And there was a lot that you said in there. Security is very important to our customers. So Travis, can you talk a little bit about securing these kinds of environments?
Sure. So secure environments on their own come with a very unique challenge. The ability for us to collaborate with the vendors and the other stakeholders in getting the products correct, because national security systems must be perfect. Our warfighters depend on it, and we owe it to them.
Well, let me pull the thread on that, Travis, a digital thread, if you will. So this digital thread is so powerful that it can be applied to cybersecurity use cases. So through our digital thread and our definitions of data, we can very precisely tag data with its sensitivity level. So we can be sure that if we're satisfying an engineering use case in a secure environment, that we're ensuring that that data does not spill or leak out of that environment because we've so precisely tagged it with a sensitivity level. And that's very powerful. And further, we can use that digital thread in cybersecurity use cases to go to our authoritative sources of truth for that cyber data, extract it, and then be able to reuse it in other areas across the systems engineering lifecycle. So again, back to your point about quality of data, that authoritative digital thread becomes the quality center for all this usage of data across the engineering lifecycle.
The Department of Defense has now a digital engineering directive, and defense organizations are going to have to work to meet that objective. So how do you recommend that they begin that journey?
Well, Theresa, I often start by saying it's not an all or nothing proposition. So organizations can iteratively advance their digital engineering approach by looking at a use case that's particularly relevant or perhaps painful, applying this automation, modernizing it just one process at a time, allowing them to see that return on investment, whether it's through a better quality product or it's a faster execution of that task. So they can work in an agile systems engineering methodology to improve their processes over time.
Travis, what are your thoughts from a program management perspective?
So from a program manager's standpoint on the directive, I would ensure that the customers are aligned with their stakeholders and vendors to ensure that there's a collaboration there so they are meeting the directive.
Well, and another point, Theresa, is although there is guidance now in acquisition to adopt digital engineering, we recommend usage of digital engineering not because we have to, but because it just makes sense to, because the savings are so great, the quality is so great, the speed is so great that on these programs where we're talking about millions of pieces of data, really a large amount of data, it's necessary for us to do it.
Right, and I really like the security conversation, right? Because it's all this done securely to protect our customers' information.
That's right.
So we're almost out of time. So I'd like to give you both the opportunity to share a final thought. Travis, would you like to start?
So I know when you had mentioned the ASI capability, one buzzword that we did not use was zero trust. That certainly is what can fall in there too with that authoritative data for the warfighters that are out there today. So they have that absolute guarantee for the mission that that data is secured.
And building on that digital thread it works very well with a zero trust methodology because it gives a single point where we are recognizing authoritative data and we know exactly how to secure it. For me, Theresa, the final point I want to mention is the usage of simulation. We haven't talked about a really powerful use of digital engineering. So when you go and get authoritative data in the design of a system, you can then simulate it to ask questions about how it will perform and parametrically analyze that system design before you have to go out into the field and build something. Whether that's an air system, a space system, these can be very expensive even in prototype phases. So being able to use that authoritative data to simulate a system ahead of time can offset any kind of upfront investment and in fact realize a greater return on investment by being able to simulate very accurate models of the system.
Certainly enhances program planning.
That's right.
Yeah. I'd like to thank you, Mike and Travis, for your time today in this meaningful conversation as our customers begin their digital engineering journeys. And I think this is a great place to end our conversation. If you would like more information about GDIT's digital engineering expertise, please go to gdit.com/perspectives.